Okay, so now we're going to use the Pythagorean theorem to find the distance between 2 points on a graph. Whenever it says to keep your answers in simplest radical form if necessary, that just means to simplify your radical as much as possible. We're not going to round our answers. So we're going to plot these 2 points on the graph. Negative 2, 5 would be this point here, and 2, negative 3 would be this point here. Connecting those 2 points together, we're really trying to find this length, which we cannot count and say, okay, it's about 1, 2, 3, 4, 5, 6, 7, 8. You can't do that. When you are finding the length of a diagonal on the graph, you cannot use a counting method to help you figure out the length. Instead, what we're going to do is we are going to connect these 2 points using a vertical and a horizontal line. So starting at my top point and going down vertically, 1, 2, 3, 4, 5, 6, 7, 8 units until that vertical line is even with my bottom point. You can count vertical lines, you can count horizontal lines. So now I'm going to draw a horizontal line in 1, 2, 3, 4. And guess what? A vertical and horizontal line create a right angle, a 90-degree angle. And so we technically have a right triangle. And we are going to be finding the hypotenuse of this right triangle. I'm going to label my side length of 8a, my side length of 4b, and now I'm going to use the Pythagorean theorem. A squared, which is 8 squared, plus b squared, which is 4 squared, is equal to c squared. 8 squared is a 64, plus 4 squared, which is a 16. This is equal to c squared. A 64 plus a 16 comes out to be an 80. Now I'm going to take the square root of both sides. We're not going to round, we're going to simplify this radical. 80 is divisible by 16. I can split up 80 into a 16 times a 5. The square root of 16 is a 4. I take that 4 out, I cross off my 16. The square root of 5 cannot be done. 4 root 5 is your answer in simplest radical form. Now, number 2, we don't have a graph, so I'm going to show you how to do these types of problems without a graph. Technically, what we did between these 2 points was we found our rise and we found our run. And my rise is one leg of my right triangle, and my run is another leg of my right triangle. Both your rise and your run, when we're dealing with these right triangles, need to be positive because we cannot have negative lengths on a triangle. You can't have a measurement that's negative. So, doing my rise over run, my rise is my change in y values. From a 3 to a 7, that is a distance or a difference of 4 units. That's your rise. My run is my difference between my x values, the 2 and the 5, which is a distance of 3. Now, if you ever wind up with a negative distance in these types of problems, all you need to do is make it into a positive distance, because we cannot have a negative length in a right triangle. Our legs of our right triangle need to be positive. So always make it the positive version of your rise and run. So again, my rise was the difference in my y values, which from a 3 to a 7 is a 4. My run was my difference in my x values, which from a 2 to a 5 is a difference of 3. Now, one of those you're going to label as A, the other you're going to label as B, and we are finding C. So I'm going to do A squared plus B squared equals C squared. So I do not need a graph to do these types of problems. A 3 squared is a 9, a 4 squared is a 16. A 9 plus a 16 is a 25. And taking the square root of 25, 25 is a perfect square. We wind up with the square root of 25 being 5. All right, so that's finding the distance between 2 points on a graph, and then 2 points if we don't have a graph, how to do it. Now we're going to look at finding the diagonal of a rectangular prism. The diagonal of a rectangular prism is the longest length within your rectangular prism. The diagonal of a rectangular prism extends from 2 complete opposite corners of your figure. For example, if we look at number 3, the diagonal of your rectangular prism in number 3 is what is drawn in for you. Sometimes you will need to draw the diagonal in yourself. Now they started the diagonal at the top, back, right corner. The opposite of top is bottom, the opposite of back is front, the opposite of right is left. So the diagonal goes through this rectangular prism and ends at the bottom, front, left of your prism. So it's complete opposite corners. Same thing with number 4. They decided to start this diagonal at the top, back, left corner. And the complete opposite of top is bottom, of left is right, and of back is front. So they ended the diagonal at the bottom, left, front side of our rectangular prism. It goes through the rectangular prism. Now, the diagonal can start anywhere. For example, maybe you started it at the top left front corner and went through your rectangular prism all the way to the bottom right back corner. That's okay. All right, it's up to you where you want to start your diagonal, but they actually drew the diagonal in for you for numbers 3 and 4. So now what we're going to do is we're going to find that diagonal. I'm going to label that diagonal D. D will stand for diagonal. Now, if I connect the top back corner of this diagonal with this straight vertical line, and this line here, that creates a right triangle. Now we do not have this line down here that I'm highlighting in yellow. We need to find that line. I'm going to label that C. How we find C is we use this right triangle, where this is a right angle here, and on that yellow right triangle, we have enough information to help us find C. I'm going to label my 12 as A and my 5 as B, and I'm going to use the Pythagorean Theorem on that yellow right triangle to find C. So I do A squared plus B squared is equal to C squared. A 12 squared is a 144. A 5 squared is a 25, and this equals C squared. A 144 plus a 25 gets you at 169, and that equals C squared. And taking the square root of both sides, 169 is a perfect square. We get C to be equal to 13. So now I'm going to replace the C with 13. And now I'm going to use this blue right triangle to help me find my diagonal. The 13 can be labeled as A, the 6 can be labeled as B, and my diagonal is my hypotenuse. So I do 13 squared plus 6 squared is equal to my diagonal squared. The 13 squared is a 169. A 6 squared is a 36, and that equals my diagonal squared. A 169 plus a 36 is a 205. we want to write our answer in simplest radical form. And actually, I believe that 205 does not have any perfect square factors. So we would just leave it as the square root of 205. That's your answer. All right, number 4. My blue diagonal with this red vertical line and this yellow line create a right angle. Now my red vertical line is the same length as this vertical line over here, so my red vertical line is a length of 5. But my yellow line, I don't know what that is. I'm going to label that as C, and sorry, I'm going to label my diagonal as D. So on this right triangle, we don't have enough information to find my diagonal. So I need to use this right triangle that I'm highlighting in purple, and this is my right angle here. And one of my legs is 8. I'm going to label that as B. My other leg is the same as this here, which is 6. So this is 6. I'm going to label that as A. And we need to find C on this purple right triangle, which is my hypotenuse. So I'm going to do a 6 squared plus an 8 squared is equal to a C squared. So I have a 36 plus a 64 is equal to a C squared, which gives me a 100 is equal to a C squared. Taking the square root of both sides, I can do the square root of 100. C comes out to be 10. So I'm going to cross off C and put 10 there. And now on this blue right triangle, I have enough information to find my diagonal, which is my hypotenuse. I'm going to label my 5 as A and my 10 as B. And now I'm going to do A squared plus B squared equals C squared. So I have a 25, I'm sorry, that should be a 10 squared, not a 100 squared, but a 10 squared does equal a 100. And so I get a 125 is equal to my diagonal squared. And taking the square root of both sides, it does say to do this in simplest radical form. 125 can be split up into the perfect square of 25 times the non-perfect square of 5. And the square root of 25 is 5. So I take that 5 out and I cross off 25. And then I have a 5 remaining underneath my radical. And so my diagonal in simplest radical form is 5 root 5. This brings us to the end of the level 2.